Data science is a multidisciplinary field that combines techniques from mathematics, statistics, computer science, and domain knowledge to extract valuable insights and knowledge from data. It involves the process of collecting, analyzing, interpreting, and visualizing data to uncover patterns, make predictions, and drive decision-making. To demystify data science and understand its real-world applications, let's explore some key concepts and steps involved in the data science workflow. 1. Problem formulation *. The first step is to clearly define the problem or question you want to address. This involves understanding the business context, identifying the objectives, and defining measurable outcomes. 2. Data acquisition *. Data can come from various sources such as databases, APIs, sensors, social media, or other external datasets. It's important to gather relevant and high-quality data that aligns with the problem at hand. This may involve data collection, data cleaning, and data integration. 3. Exploratory data analysis EDA involves exploring the data to understand its structure, identify missing values, outliers, and patterns. Techniques such as summary statistics, data visualization, and statistical tests are used to gain insights and form hypotheses about the data. 4. Data preprocessing * Raw data often requires preprocessing before analysis. This step involves handling missing values, dealing with outliers, normalizing or scaling data, and transforming variables to ensure they are suitable for modeling. 5. Feature engineering * Feature engineering is the process of creating new features or transforming existing ones to improve model performance. This may involve selecting relevant features, creating interaction or polynomial features, or applying dimensionality reduction techniques. 6. Model selection and training * Based on the problem type, classification, regression, clustering, etc., suitable models are selected. These models can range from traditional statistical models to machine learning algorithms such as decision trees, random forests, support vector machines, or neural networks. The models are trained using labeled data, and their performance is evaluated using appropriate metrics. 7. Model evaluation and validation * The trained models need to be evaluated to assess their performance and generalization ability. This involves splitting the data into training and testing sets, performing cross-validation, and using metrics like accuracy, precision, recall, or mean squared error to evaluate the models. 8. Model deployment and monitoring * Once a satisfactory model is selected, it can be deployed into production systems or integrated into decision-making processes. It's important to monitor the model's performance over time and update it as new data becomes available. 9. Interpretation and communication * Data scientists need to interpret the results of their analyses and communicate them effectively to stakeholders. This involves visualizing the findings, creating reports, and presenting actionable insights that drive decision-making. Real-world applications of data science span across various domains, including business analytics * forecasting sales, customer segmentation, market basket analysis, and churn prediction. Healthcare * predictive modeling for disease diagnosis, drug discovery, patient monitoring, and personalized medicine. Finance * fraud detection, risk assessment, algorithmic trading, credit scoring, and portfolio optimization. Marketing * customer behavior analysis, recommendation systems, A/B testing, and social media analytics. Transportation * route optimization, demand forecasting, traffic analysis, and predictive maintenance. Manufacturing * quality control, predictive maintenance, supply chain optimization, and process improvement. By applying data science techniques, organizations can gain valuable insights, optimize processes, automate decision-making, and drive innovation. However, it's important to note that each application